Hi students, today I am going to explain the lesson force and pressure for class 8 students. So what is force? A force is pull or push upon an object. So when an object is taken, whether we push it or pull it, it is called force. So that what happens results from the object's interaction with another object. So from when one object interacts with another object, it may get pulled or pushed so that it will be moved. That is called force. So the turning effect of a force is more if the distance between the point of application of force and the hinge on the door is more. For example, one door is there. So if the hinge on the door, so means that which we hold the door, if it is between the point of application and the hinge, if the distance is more, then the turning effect will be more. So how it is, let's see in the lesson. So it is given a special name called moment of force. Then we discussed about force. Then what is pressure? It is the force per unit area. So pressure is also a force, but when we measure it for a unit area, it is called pressure. So solids, liquids, gases, all the states of matter will exert this pressure. Even atmosphere also exerts pressure. So many activities are done in this lesson to explain the pressure and force. Let's see. So first, what is force? So we have read that body which does not change its position with respect to surroundings is said to be at rest or stationary. When a body is there, if it is not moving, means it is not changing its position according to the surrounding, then we can say that body is at rest or in stationary. When it changes its position with respect to its surroundings, then we can say that the body is motion or moving body. So if it is not changing its position, it is at rest. If it is changing its position, it is called moving body or motion. So we already discussed what is a force. It is a push or pull. So a force is a cause. So how the body moves? Because of force. So it is a cause which tends to result in moment or change in size, shape of the body. So when a force is applied, it may cause to move the body or to change its size, shape, etc. So a force when applied as push or pull on a stationary body which is free to move can produce motion on it, and if applied on a moving body, it can change the speed of the motion. So when a force is applied, whether we push or pull on a stationary body, means the body which is at rest, then which is ready to move, which has access to move, then it will produce motion. And when we apply force on already moving body, then the speed of the motion will be increased. Similarly, the shape or size of a non-rigid body can also be changed by applying force. If we apply more force, then the shape of a non-rigid body. Non-rigid means, rigidity means ability to withstand the shape. It cannot change the shape easily. Non-rigid means it can easily change the shape. So that like that body, if we apply force, it will change the shape or size. If an object does not move on application of force, or its size and shape does not change, then in the language of physics, we say that force applied is not fruitful. So we are applying force. If a body is there, it is not moving. If you are applying more force, so it is not moving, or it is not changing its size, or it is not changing its shape, then we can say that force is not fruitful. It is not fruitful means it is not good. So force is not useful. Yes, no? Then, so we can say some examples for this. A grass roller initially at rest, when pulled begins to move. So a grass roller already it is at rest. When we pull it, it will move. A fielder when catches a ball stops the moving ball. A moving car slows down on applying brakes. A push on a swinging girl speeds up. A girl is swinging on a swing already. When we push it again, her speed will be increased. So a player when applies force by his hockey stick on the ball. So a player who is playing hockey, if he applies some force on the ball, then the direction of motion of the ball changes. So when force is applied, as a stretch or squeeze on a body which is not free to move, it changes the size or shape of the body. So whatever is, when we are applying the force on the body which can stretch or which can become small, squeeze, then and it is not easily movable, then it will change its size or shape of the body. For example, a rubber string, when we stretch it, its length will increase. Like that only a table of gum, on squeezing a table of gum, its shape changes. Like this, when we can stretch or squeeze like that bodies, it will change its shape and size. So at last, how we can define a force? Force is that cause which changes the state of the body, whether it is at state of rest or the state of motion, or it changes the size or shape of the body. So it will change from rest to moving, from moving to maybe to rest, or more fast, or it may change the size or shape of the body. Like this we can define the force. Then here note, a force does not change the mass of the body on which it is applied. If you apply the force, the mass, that is weight, will not change. We cannot see a force, however we can see or feel the effect of the force. We cannot see the force, but we can feel the force, or we can see the effect of the force. What happens after force is applied? Then a force is expressed by stating both its magnitude and direction. Means a force, when we apply, it may change its magnitude, how much force, magnitude is how much force we are applying, and it may change the direction of the body also. So a force is represented by an arrow like this. The length of the arrow is a measure of its magnitude. How much big arrow, that much force we are applying, and the arrow head shows the direction, in which direction we are applying the force. Then what is the units of force? We know that the SI unit of force is Newton. Why Newton? Because it is named after an English scientist, Sir Isaac Newton. So he did so much of research work on the force. So that's why his name is given. So it is represented by capital N, Newton. So 1 Newton is defined as a force which applied on a moving body of mass 1 kg in the direction of its motion increases its speed by 1 meter in 1 second. So 1 Newton, how we can tell a force is applied on the body, in which direction it is moving, that in that direction only, on a body which is of mass 1 kg, so that its speed will be increased to 1 meter in 1 second. So we have read that our earth attracts each body towards it. The force of attraction exerted on a body by earth is called weight of the body, or the force of gravity that acts on the body. We will say, I am 50 kgs, I am 60 kgs, I am 10 kgs, I am 20 kgs. What is this weight? Weight is with how much force of attraction the body is attracting. We are attracted to the earth. So whatever is the body which we are weighing, how much force of attraction it is attracted to the earth by gravity. That is nothing but weight of the body. So our earth attracts each body towards it. We know that we have gravitational force on the earth. It will attract the body. So this force of attraction exerted on a body by earth is called weight, or the force of gravity that acts on the body. So the force of gravity or weight of the body is different at different places on the earth. So this force of gravity or weight will be different on different places. At a place, the force of gravity on a body of mass 1 kg is called 1 kgf, or 10 newtons. In other words, 1 newton is the force of gravity at a place of 0.1 kg, 100 grams mass. So the unit of force kgf and n are related. How? So 1 kgf is equal to 10 newtons. Remember this, 1 kgf is equal to 10 newtons. In other words, 1 newton is the force that we have to exert to hold a mass of 100 grams. So to hold 100 grams on our palm, we need 1 newton of force. So force of 1 newton to hold 100 grams of weight on our palm. Like this they gave. So and 1 kgf is equal to 9.8 newtons. That is nothing but 10 newtons nearly. So they gave 10 newtons, but exactly is 9.8 newtons. Then, so turning effect of a force. So we have read that if a force is applied on a stationary rigid body, when we are applying a force on a stationary, means rest, which is at rest, which is not moving, and a rigid body which does not change its shape, like that body, it starts moving in a straight line in the direction of force. In whatever is the direction we are giving the force, in that direction it will move straight. So for example, a ball, we pushed it with a force, then it will move in the direction of motion in which we are giving. Now, if the body is not free to move, if it is not free to move, but it is pivoted at a point O, so we tied it at a point O, and force F is applied at the suitable point A. So we are applying a force at a point A. It begins to turn about the point O. So it will be rotating because it is not free to move like this. It is tied. So what happens? It will be rotating about its own axis. The vertical axis passing through the point O, about which the body turn, is called axis of rotation. So it is called from point O. So the point which is passing through the point O, it is called axis of rotation. In pushing, the wheel begins to turn about its pivoted point O. So the wheel will works like this only. So the wheel will be rotating on its axis like this. Then similarly, when the handle of a door either pushed or pulled, the door begins to turn about the hinges which hold the door at rest. So what happens? So we will just handle of the door, we will push or pull to open or close the door. So what happens? It will turn at the hinges. What are hinges? So something attached the door to the wall, we can see there. They are called hinges. So which will hold the door at rest. It will not allow to move. So thus a force which is push or pull, so has turning effect on the body. It will make to move, turn the body when it is not free to move in a straight line, but is pivoted at a point about which it can turn. When it is free to move, then it will result in moving in a straight line. When it is not free to move, then it will rotate, turn. Okay. Then, so what are the factors that affect the turning of a body? The turning effect of a force on a body depends on two factors. So how much force we are giving, the perpendicular distance of the force from the pivoted point. So what are the two factors is how much force we are applying, and also the distance between the tied point to the force. So let's see, the larger the magnitude of force applied, more is the turning effect. If we more force if we apply, more turning effect will be there. Then larger the perpendicular distance of a point at which the force is applied from the pivoted point, more is the turning effect. So from here we are giving force and this point is O. So if the distance is more, then there will be more turning. Okay. So like this, these are the two factors which affect the turning of the body. Then some examples in our daily life they gave. To open or shut a door, we apply a force. Yes, no. To open or close the door, we apply a force F normal to the door at its handle P. So we are applying a force at a handle P. So which is provided at the maximum distance from the ring, from the hinges. So hinge illide. So hinges are there here which are attached to the door. So the distance from the hinge to the point, pivot point which we handle P is more than what happens. We can notice that if we apply the force at a point Q, so if we apply here the force, much greater force is required to open the door. It is very difficult to open the door. More force is needed. If the force is applied at the hinge R, we cannot open only. If we push here, we cannot open or close the door. It is very difficult. If we apply force here Q, then more force is needed. But if we apply force here, which is maximum distance, then easily we can open or close the door. So turning effect will be more if the pivot point is very long distance to the pushing point, or we are applying the force. Then thus the handle P is provided near the free end of the door, so that there is a small force at a larger perpendicular distance produces more turning effect to close or open the door. Then here see the upper circular stone A of a floor grinder. This is hand floor grinder is provided with handle H here. It is provided very long distance to the rim here from the pivot. This is pivot point which is attached above and below stones are attached here with a point, so that they give maximum distance so that it can easily be rotated about the iron pivot point P. So by applying a small force with the help of handle, we can rotate it easily. Then a potter's wheel. So if we see pivoted at the center, the potter turns the wheel by a stick at the rim of the wheel. So at the last he is rotating, so that because of maximum distance, for simple applying force simply he can rotate easily. Then a carpenter using a drilling machine which is provided with a handle, so that by applying less force at the end of the handle, the drill can easily be turned easily. So in a car steering wheel, the driver applies a force at the point of the rim, here say rim, so that it will rotate easily with small force. So in a bicycle, again, to turn the wheel, the force is applied to the pedal, so that the distance of force from the axle of the wheel is increased. Then a spanner is used to tighten or loosen a nut, has long handle, so that it will produce more turning effect with small force. So all these are the examples how the factors will help us in our daily life to handle the turning effect of a body by small force. So we can conclude that from the above examples, we can conclude that the turning of a body about the pivot does not depends not only on the magnitude of the force, but also it depends on the perpendicular distance of the force from the point of rotation. So from the point of rotation, how much distance it is there. If larger the perpendicular distance, we need less is the force needed. We need only small force to turn the body. Actually, the turning effect on a body depends on product of both magnitude of force and perpendicular distance of the force from the pivoted points. So turning effect depends on both the factors, how much force we are applying, how much distance it is. The product is both is called moment of force, or it is also called torque. So in other words, we can say body turns about the pivoted point due to the moment of force. So then what is moment of force? So the moment of force is equal to the product of, I told the two factors, magnitude of force and the perpendicular distance of the force from the pivoted point. So how much force we are giving, and from the pivoted point how much distance is there. So consider a body which is pivoted at point O. So it is pivoted at point O. If a force F is applied on the body in the direction of FP, so it is given here in the FP, the force is unable to produce linear motion of the body in the direction, because the body is not free to move. It is not free to move, so it is not moving. But this force turns the body about at point O. So it will turn the body to the O as shown in the figure. The perpendicular distance of the force from the pivoted point O is OP. So what is the perpendicular distance from the force? OP. So moment of force is nothing but force into distance, how much distance it is. So force F into perpendicular distance is OP. So F into OP. So moment is equal to F force into OP, F into OP. So next, so what are the units? We already discussed units of force. It is newtons. Yes, no. So what are the units of moment of force? We know the unit of force, and we also know the unit of distance. So yes, a unit of force is newtons and distance is meter. So Newton into meter, so Newton meter. So units of moment is nothing but Newton meter. We can represent it as N, capital N, small m. Okay. So our torque is nothing but Newton meter. In CGS units, if you want to write, it is dyne into centimeters. But if the force is measured in gravitational unit, if you are applying the force in gravitational unit, then the moment of force in SI unit is kg of m, and in CGS grams f. Yes, no, like this we can tell. And 1 Newton meter is equal to 10 to the power of 5 dynes into 100 centimeters. 1 meter is equal to 100 centimeters. 10 to the power of 2 they gave. So if bases are same, then we can add the exponent. So 10 to the power of 7 dyne. So 1 kgf is equal to 10 newtons, or nearby is 9.8 newtons. They gave that only. And 1 gram F is equal to kg in gram. Kg is converted into gram. Meters are converted into centimeters. So 989 centimeters. So like this they gave the units. So you can remember Newton meters easily, and kg of meters, that is equal to 9.8 N. So Reena has to apply a minimum force of 1.5 newtons on the handle of the door. So he is applying she is applying some force 1.5 newtons on the handle of the door of width 1.2 meters to open it. So its width is 1.2 meters. They gave the force and the distance. So moment, how we can calculate force into distance? So 1.5 into 2, 1.2, that is nothing but 1.8. So if she wants to open it by applying the force at the midpoint between the handle and the hinges, then distance 0.6 from the hinges, she will have to apply a force such that F into 0.6 is equal to 1.8. So here it is multiplying, so it goes here and divides. So she wants 3 newtons energy. So yes, no. So only she wants 1.5 newtons when the distance is 1.2 meters. When the distance is less 0.6, then she wants more force, that is 3 newtons. So if the distance is increasing, more force is required. Like this we can conclude. Next, what is thrust? A force can be applied on a surface in any direction. If a force is applied on a surface in any direction, and if the force is applied on a surface in a direction normal to the surface, the force is called thrust. So let's explain this. So thus the force acting normally on a surface. So when a surface on the surface, if we are applying the force, it is called thrust. For example, a body when placed on the surface exerts a thrust on the surface equal to its own weight. So if a body is there, it will exert a thrust, so on its surface, by how much weight it is, that much weight. So unit of thrust is 1 kgf is equal to 1000 gf. 1 kgf is equal to 10 newtons. 1 newton is equal to 100 gf nearly. So what is the effect of thrust? What happens? So the effect of thrust depends on the area of the surface on which it acts. It directly depends on the how much area that surface is, and smaller the area on which the thrust acts, larger its effect. So if the surface area is small, then thrust will be more, but the effect of thrust is less on a large area. So they are inversely proportional. More surface area, less thrust. More thrust is there, then lesser thrust. Like this we can tell. So for example, we will understand with this example. See, if you stand on a loose sand, a boy is standing on a loose sand, your feet will sink deeply on the sand. So what we can see, our feet will go into the sand. Yes, no. But when we sleep on the sand, when we lie on the sand, your body does not sink. Why? Because in both the cases, thrust exerted on the sand is same. Because when we stand, we have small area touching. So surface area is small. So what happens if the surface area is small? Thrust is more. That's why force is more pressure. Thrust is nothing but force. So it will sink. Here more surface area, less thrust. So our body will not go down in the sand. Like this we can explain same thrust but different effect because of different surface area. Then one more example. If you hammer a nail holding it with its flattened end, see here, reverse. If we hold like this and we are hammering, then what happens? It is very difficult to go into the block. If sharp end is kept, then it will go very fastly. Why? Here more surface area, that's why less thrust. So more force is required to do that. Again here less surface area, more thrust. So with small force only it will go off. The reason is when thrust acts on a flattened end, the effect of thrust is small. But when the same thrust acts on a sharp end, the effect of thrust is more. So like this it is explained. Next is pressure. The effect of thrust is expressed in terms of quantity called pressure. So this thrust only, when we express it in some quantity, it is called pressure. More the effect of a given thrust on a surface, we say the thrust exerts more pressure on the surface. And if less is the effect of thrust on the surface, we say thrust exerts a less pressure. So when they say here, what we can say, so more the effect of a given thrust on a surface, we say thrust exerts more pressure on the surface. So here less pressure it is giving, here it is giving more pressure. So what is pressure then? Pressure is nothing but thrust per unit area or force per unit area. Thrust is nothing but force, no. So thrust by area is pressure. So it is denoted by P, pressure. So if the thrust is F, so force I already told. So pressure is equal to force by area. So force for some area, we can say it is pressure. Then, so what are the units of pressure? We know that SI unit of thrust is Newton and the area, that area is meter square. So the SI unit of pressure is Newton per meter square. How? So I told force by area. Force is Newtons. Area is meter square. So Newton by meter square. So like this we can say the units of pressure is Newton by meter square, or it is also called Pascal, because again with some scientist, so his name is Blaise Pascal. So this is named after him. So 1 Pascal is the pressure exerted by a thrust of 1 Newton. So we know that 1 Pascal is nothing but a pressure, that is equal to force by area. Force is 1 Newton by area is 1 meter square. So 1 Newton by meter square. 1 Pascal is equal to 1 Newton by 1 meter square. So like this we can express. The bigger unit of pressure is kilopascal. So 1 kilopascal is equal to 1000 pascals. If the thrust is measured in kgf and area in centimeter square, then kgf per centimeter square. So the atmospheric pressure is expressed in 1 atmospheric pressure is equal to 76 centimeters of mercury column, or if we want in pascals, 1.013 into 10 to the power of 5 pascals. Then we will see what are the factors affecting pressure. So we saw factors affecting the turning effect of fraction. So we saw the turning effect of the force. Then we are seeing here how the pressure will also. So we know that it depends on area and also how much thrust, because pressure is equal to force by area. So it depends on 2 factors. What is the thrust and area? Thrust means force, force area. It depends on 2 factors. How it depends on the area? Let's see. When you stand on sand, when we are standing on a sand, a thrust equals to your weight acts on a smaller area. So when we are standing on a sand, so all the body weight will be pressured on a sand with our foot in a small area. So we will sink more. But we sleep on the sand, the same thrust acts on a large area and so exerts less pressure. So hence you sink less. Similarly, when you hammer a nail with its flattened end resting on a wooden block, thrust exerted by you acts on a larger area, so less pressure acts on the nail. Hence, do not go into the block. So when we are inserting a nail in the this end, because of more surface area, so thrust less pressure is there, so it will not penetrate. It is very difficult, more force is required to do that. But when you hammer the nail with its sharp end resting in the block, the same thrust acts on the smaller area, so more pressure acts on it, so it easily penetrates. Like this we can say. Then here see 3.15, here it shows a block of mass of 10 kg. So 10 kg and dimensions 40 into 20 into 10 centimeters. See, lying on a table, on its side 40 into 20. So it is lying into 40 into 20 side. The thrust exerted by the block on the table is equal to the weight of the block. So what is that is 10 kgf. Its area is 10 kgf. So thrust, that is 10 kgf, and area is 800 centimeter square they gave. Then the pressure is nothing but thrust by area, 10 by 800. We can calculate 10 by 800, that is equal to 0.125 kgf. Then so the same block, if we turned it in the 20 centimeter here, and because less area it is, so 40 centimeters like this and 10 centimeters like this. So the thrust exerted by a block, again area is 20 into 10, 10, so 200, and we can say 10 by 200, it is 0.05. So thrust is 0.05. Here 0.0125, here is 0.05. So less surface area, more pressure. More surface area, less pressure. So we can compare like this. Then, so from this we can say the pressure exerted by a body depends on the surface area on which the thrust of the body acts. Smaller the surface area, more the pressure, and larger surface area, less is the pressure. So like this we can tell. Then, how the dependence of pressure on thrust. So a thin body is standing on bricks kept on a bed. So a thin body is, thin boy is, so he is standing on a bed. So with less pressure, he exerts some pressure due to his weight. Because of his weight, less thrust. So then, a fat boy is standing on the same bricks kept on the bed. So what happens? The pressure exerted by the fat body is more due to his excess weight. So the greater the thrust on a surface, more is the pressure on it. So smaller the thrust on the smaller surface, less is the pressure. So like this we can tell. So more the thrust, more the pressure. So thin boy standing on a bed, less pressure. Fat boy standing on a bed, more pressure. So same area we took here. So less thrust, more thrust. Then, so what are the examples in our daily life? So decrease in area increases the pressure. So a nail, we already discussed this, or a bot pen has one end pointed and sharp. So and one other is blunt and flat. So if we apply the force on pointed end, it will exert greater pressure on this area, and so it will go very fastly. So on the blunt end, it will not go faster. So then, the cutting tools like blades, knives, etc., they have sharp edges, means very small area. So pressure applied by a force is more. Then pointed heels of a footwear exert more pressure on the ground than regular flat heels. So a lady with pointed heel stands find it difficult to walk on a muddy road than a tar road. She cannot easily walk on a muddy road. Then the narrow heeled sandal of a girl hurts more than broad heeled. So when we see the sandals, there are two types, a very pointed heeled and some broad heeled shoe of a boy. More pressure is exerted by a girl than the exerted by a boy. So the heel is more narrow than heel of the shoe of the boy. Then, so increase in area decreases the pressure. How? So heavy trucks have 6 to 8 tires instead of the conventional 4 tires. So heavy trucks will have more tires. More number of tires will increase the area of the contact. So it will reduce the pressure. If only 4 tires, then less area will be there. Speed will get affected. A camel can move conventionally in the sand as compared to horse. When we compare to horse, a camel can easily move because camel has a very broad feet. So more surface area, less pressure on the sand. So you can easily walk. Then skiers use long flat skis to slide over the snow. So when they are sliding, they will use more long flat so that the more area of the contact, less pressure. So they cannot sink in the snow. Then army tanks are usually very heavy and they exert large pressure on the ground if they move on wheels. Hence they are made to move along the broad steel tracks called caterpillar wheels of tanks. So they are made up of, because of more pressure, it is very difficult to move on the road. So they are made up of steel tracks called caterpillar wheels. So it will increase the surface area. So less pressure is required. So they will not sink in the ground. Then foundation of buildings are kept wide. Foundation, when we are constructing a house, the foundation of buildings are kept having large surface area so that it will not put more pressure on the ground, and so because of this the building will not sink into the earth. Then potter wears turban on his head when he has to carry heavy loads. So we see when we keep the pots on the head, they will wear some cloth like material like turban so that more surface area, so that less pressure, so it will not fall down easily. Then school bags, shopping bags have broad straps or belts so that it will increase the area, so pressure on the hand or shoulder will be reduced. Then wide wooden sleepers are placed below the railway tracks, see here, so that the pressure exerted by the rails on the ground will become less. So these are all the examples in our daily life, how the less surface area will help to reduce the pressure. So from this we can conclude the differences how thrust and pressure will be. So thrust is sum total of force acting perpendicular to a surface, and pressure is thrust per unit area. So thrust don't want area. but pressure wants area. So it is independent of area, it depends on the area. So SI unit of thrust is newtons, and here it is pascals or Newton meter square.